Welcome back to Thinkin' Bits, where we solve coding challenges and explore what AI can really do. FizzBuzz has become one of the most famous programming interview questions in software engineering, and there is a clear reason for that. On the surface, it looks almost too easy. You print numbers, replace some of them with short words, and move on. Because it looks so basic, many developers underestimate it. They walk into an interview feeling confident, then freeze when they have to turn a few simple rules into clean working code under time pressure. Interviewers love FizzBuzz because it quickly shows whether a candidate can think carefully, use loops and conditions correctly, and avoid small logic mistakes. It is not about flashy frameworks. It is about fundamentals. Today, we will watch Cursor, an AI coding assistant, face this classic challenge completely cold. No hints, no starter code, just the problem itself. Can Cursor solve FizzBuzz correctly, and would that solution survive a real coding interview? Let's find out together. So, what exactly is the FizzBuzz challenge? In the classic version, you print the numbers from 1 to 100, but 3 special rules change some of those numbers into words. If a number is divisible by 3, you print the word fizz instead of the number. If a number is divisible by 5, you print buzz. And if a number is divisible by both 3 and 5, you print FizzBuzz. Every other number is printed exactly as it is. Let me make that concrete with spoken examples. The number 3 is divisible by 3, so it becomes fizz. 5 is divisible by 5, so it becomes buzz. 15 is divisible by both 3 and 5, because 15 equals 3 times 5, so it becomes FizzBuzz. 16 is divisible by neither 3 nor 5, so it stays 16. 30 is divisible by both again, so it also becomes FizzBuzz. Those examples matter because the order of your checks decides whether the output is correct. If you only check for 3 first and stop there, 15 would incorrectly become fizz instead of FizzBuzz. That combined case is the detail interviewers watch for, and beginners often miss it. Now, we open Cursor and send the challenge. On screen, you can see a clean chat prompt with no starter file and no extra guidance. We simply ask Cursor to solve the FizzBuzz problem in Python and print the results for numbers from 1 to 100. That is all. There are no hints about using the modulo operator, no reminder to check the combined case first, and no implementation details of any kind. Cursor receives the same kind of brief instruction a candidate might hear in an interview. Here are the rules. Write a working solution. Watching what happens next shows how well the AI can turn plain language into real Python without being steered. Cursor starts by interpreting those rules as a programming task. Like many coding models, it breaks the problem into pieces: a sequence of numbers, a way to inspect each number, and conditions that decide what to print. You can watch it draft a loop, introduce divisibility checks, and assemble an if, elif, else structure that covers every case. It does not invent a fancy framework or pull in an unnecessary library. It stays with core Python, which is exactly what you want for a problem like this. The generation feels fast, but behind that speed is pattern recognition from countless similar solutions. Cursor reconstructs a reliable approach and shapes it into readable code. Within moments, a complete script appears, ready for review. Now comes the most important part: a full walkthrough of the solution, line by line, as if we are teaching Python from scratch. Cursor begins with a for loop. In Python, a for loop lets you repeat an action for every item in a sequence. Here, the sequence comes from the range function. Writing range from 1 to 101 produces the numbers 1 through 100, because the end value in range is exclusive. That small detail trips up beginners all the time. If you write range to 100 only, you stop at 99 and miss the final number. Inside the loop, each number is tested with the modulo operator. Modulo gives you the remainder after division. So if a number modulo 3 equals 0, that number divides evenly by 3. The same idea applies to 5. This is the cleanest way to express divisibility in Python, and interviewers expect candidates to know it. Then come the conditional statements. Cursor checks the FizzBuzz case first. If the number is divisible by both 3 and 5, print FizzBuzz. That order is critical. 15, 30, 45, and 90 all hit this branch. If you checked only for 3 before the combined case, those numbers would print fizz and never reach FizzBuzz. Checking the most specific rule first protects the logic. Next is elif, which is short for else if. If the combined check failed, Cursor asks whether the number is divisible by 3. If yes, print fizz. Another elif asks whether the number is divisible by 5. If yes, print buzz. Finally, else handles everything else by printing the number itself. That else branch is what keeps 16, 17, and 19 looking like ordinary numbers in the output. A common beginner mistake is stacking independent if statements without else, which can print multiple lines for one number. Another mistake is using regular division instead of modulo, or forgetting that range stops before the end value. Some beginners also check for buzz before FizzBuzz and accidentally break the combined case. Cursor avoids those traps. The generated code is readable because each branch has one clear job, the structure is simple, and there is no clever trick hiding the logic. Readable code is easier to explain in an interview and easier to trust when you run it. When we run the program, the terminal fills with output from 1 to 100, transformed by the rules. Near the start, you see 1, 2, then fizz for 3, 4, buzz for 5, and so on. When we reach 15, the output correctly shows FizzBuzz, not fizz alone, and not buzz alone. Later, 30 appears as FizzBuzz again, confirming that the combined rule still works deeper in the sequence. Numbers like 16 remain 16, which proves the else path is alive. Scanning through the list, every multiple of 3 that is not also a multiple of 5 shows fizz, every multiple of 5 that is not also a multiple of 3 shows buzz, and every multiple of 15 shows FizzBuzz. The output matches the specification exactly. Could this solution be improved? Technically, yes, because FizzBuzz has many valid forms. Some developers write a dense one-liner with clever joins and nested conditions. That can look impressive, but it is often harder to read and harder to defend when an interviewer asks why it works. Others extract a helper function or collect results in a list before printing. Those changes can help in larger programs, yet for this classic challenge, they are optional. Cursor's version favors clarity over cleverness. In most interviews, and in most real code bases, readability wins. A solution you can explain out loud in 30 seconds is usually stronger than a trick that needs a long apology. So yes, alternatives exist, but this style is a smart default. Final verdict: Cursor earns a 9 out of 10 on this FizzBuzz challenge. The solution is correct, idiomatic, and easy to explain. In a coding interview, this would very likely pass the warm-up stage with confidence. The tiny gap to a perfect 10 is only that an interviewer might still ask follow-up questions about edge cases, automated tests, or alternative designs. Overall, Cursor handled the problem the way a solid junior or intermediate developer should. If you want to push yourself further, try solving the next challenge yourself before watching the AI. You can find more programming challenges and clear walkthroughs on Thinkin' Bits. Thanks for watching, and I will see you in the next one.